Here is a wild idea that sounds like sci-fi but is actually super practical, turning fog into drinking water. Every day, billions wake up where taps are unreliable or totally dry. Meanwhile, clouds roll by carrying fresh water as tiny droplets floating in the air. That is fog. And the crazy part, you can literally catch it. Let me set the problem. You need clean water, but drilling wells is expensive, rivers might be seasonal, and hauling bottles is not sustainable. If you live near coasts or mountains where fog is common, think Morocco, Chile, Peru, California, the challenge is those droplets are tiny, about 10 to 20 micrometers. So how do you grab them without using a ton of energy? Solution time. You put up a fence that water cannot resist. Fog harvesting nets are vertical screens made from special mesh. Wind pushes fog through the mesh. The droplets hit the fibers, stick, and merge into bigger drops. Then gravity pulls them down into a gutter. That is it. No pumps, no power, just physics doing its thing. But the mesh matters. Too tight and you block the wind, too loose and the droplets slide right by. The sweet spot is a double layer, staggered weave. Hydrophilic fibers help drops spread and merge. Add hydrophobic bits so the water lets go and drains. Think of it like Velcro for mist. Picture two tennis rackets with slightly offset strings. Fog hits the first layer, slows down, then the second. Capture rate jumps. Add tiny bumps inspired by the Namib desert beetle, and you create little highways that steer water downward faster. Numbers time, because I love data. In a decent fog, expect roughly 3 to 10 liters per square meter per day. On great days, up to 20 liters per square meter. A 40 square meter array can produce 200 to 600 liters daily. That is life-changing for a small village or a remote school. This is not theory. In Morocco's Anti-Atlas, large cloudfisher nets deliver tens of thousands of liters to village taps by gravity. In Chile's Atacama, fog collectors supply water where it basically never rains. Projects in Peru show it works across continents, and in South Africa, the same approach proves its versatility. So what does it take to set one up? Pick a site with frequent fog and steady wind, ideally 3 to 8 meters per second. Use a sturdy frame, steel poles or treated wood with guy wires. Choose the right mesh, UV stable, double layer, optimized fiber size. Install a gently tilted gutter and a sealed storage tank. Add simple filtration, a first flush diverter, sediment filter, maybe a UV step if air quality is poor. Maintenance is mostly cleaning the mesh and checking for tears. There is no fuel bill. And fog water is naturally low in salts. No desalination needed. Limitations. No fog, no water. Extreme winds demand stronger frames or flexible nets. Airborne pollution can add contaminants. Test and filter accordingly. You will not replace a city supply, but you can cover drinking and cooking. Here is a mini blueprint for a pilot. 2 3-meter poles, 4 meters apart, a 3 by 4 meter double-layer mesh panel, clamped tight, a V-shaped PVC gutter feeding a covered food-grade tank, guy wires and ground anchors, perpendicular to prevailing wind, 1 meter above ground. On a foggy morning, watch the tank fill. It is weirdly satisfying. Why I love this, it is elegant. You are not forcing nature to do anything. You are giving water an express lane from sky to cup. It empowers communities, is cheap to maintain, and scales in simple increments. If you are in a fog belt or know someone who is, this is your sign. Start small, measure the yield, and share the data. Not every solution needs to be high-tech. Sometimes the smartest move is a net, a frame, and a little wind. Turning fog into water. It is not a miracle. It is good design. And that is something any of us can build on. If this sparked an idea, share it with someone in the fog belt, and let us build one together.